if the line segment goes from one point on the circle to another, what was it called? Chord. But if it goes all the way through the circle, it's called a secant. It's a new word. So this is a chord, the other one's a secant. Okay, mostly what we're talking about today though is this one. If a line brushes up and touches the circle at exactly 1 point, so barely touches it, not 2 points, just 1 point, it's called a tangent line. Just call it tangent, I guess. So that's mostly what this lesson's about, tangent. So usually it's a line tangent to a circle. Two circles though can be tangent to each other. They touch at 1 point. Second circle wasn't that great. I give up. Alright, and then it can be, that's externally tangent. This would be internally tangent circles. They touch at 1 point inside the circle. Kind of looks like eyeballs, but there. Anyway. So these two circles are externally tangent. They touch at 1 point, but they're outside of each other. These two circles are internally tangent. Alright, but usually if they just say tangent, it just means a line that touches the circle at 1 point. Okay, rule number 1. Any questions on that? Clear as mud? Okay, if you have a tangent line and a, maybe a little bit better, okay, and a tangent that hits the line at the point of tangency, guess what happens? What's it look like? Yeah, makes a right angle. Yes, creates a right angle. It's got to hit right at that exact point though. And then if we have two tangent lines, these segments from here to here, like segment AB and segment CV, tangents from the same circle, they create congruent segments. You can prove that if I draw another radius here and it's 90 degrees and I draw this line down the middle and these two triangles are congruent by hypotenuse legs. So that means these things, AB and CB, have to be the same. Anyway, so 90 degree angle, if the radius hits the tangent line at the point of tangency, and these segments created by the tangent lines, if the tangent lines meet, are congruent. So guess what kind of questions they're going to ask today? Whoops. Well, if there's right triangles, guess what? Pythagorean theorem. So more fun with Pythagorean theorem on a few of these, the numbers problems. Okay, number 1. Circle L. Name all illustrated points of tangency. So where are the lines, tangent lines, hitting the circle at? A, B, and D. So number 1, A, B, and D. A, B, D. Number 3, what kind of triangle is triangle LBF? Okay, what do we know? LB is a what? It's a radius. What do we know about when the radius hits the tangent line? Makes a right angle. So what kind of triangle is it? Right triangle. And there's a second question. Hold on. What kind of triangle is BFD? Isosceles. The BF and DF have to be the same. That was one of the things we learned. So it's isosceles. Okay, isosceles, remember, this means two equal sides. Let's look at number 2, I guess. Since each side of triangle EFG is tangent. So triangle EFG is the really big triangle. That's drawn outside the circle. The circle is said to be blank in the triangle. So if you draw something inside the circle or inside the triangle, what was the word for that? When you draw inside? Yes. Okay, and then the second part says, and triangle EFG is blank about circle L. So the triangle is outside. What's it called? You guys probably forgot this. What's it called when you draw it around, like outside? It's not outscribed.
Subscribe to Mr. Jordan.
I think I heard somebody whisper it. Circumscribed.
Oh, circumscribed.
You guys remember like circumcenter because it was the center of a circumscribed circle. All right. Okay. Number 5.
Wait, what is it looking for on 4?
What kind of shape is it? Just look at it. You can probably figure it out. State measurement of angle LBF. How many degrees does LBF have to be? We already talked about this. LBF. Yeah. When the radius hits the tangent line, it creates a 90-degree angle. LBF is between the radius and the tangent line. So it has to be 90 degrees. That's why number 3 was a right triangle, right? Same question as number 3, basically. Number 7. Find LF if, I probably should draw that. I don't want to draw this too much. Maybe I should have started with a circle. See how ugly this gets. Xander, I said if you're taking tests tomorrow, you can turn. If you're taking tests yesterday, you can turn in the assignment tomorrow. Yikes. Oh, that was a good one. Anyway, okay. I get it. Drew a line right there too. Okay. A, B, C, D. E, F, G, L. Wait, this one's L. The other one didn't get a letter. Okay. Got it. Now, number 7 says, find LF if BL is 6, DF is 9. BL is 6, DF is 9. Find LF. Okay, I kind of warned you guys about this one earlier. So, any bright ideas on this? Yeah. So remember we've been saying this is the right triangle, right? If this is 6, this is 6, because they're both radii, same circle. If this is 9, this is 9, because tangents that meet create congruent segments. Okay, anyway, we're looking for this. Is this a leg or a hypotenuse on the triangle? The hypotenuse. You guys see the triangle right here?
Because you got like the 90-degree angle right there.
Right, 90's up here, so yeah. So how do we set it up? 6 squared plus 9 squared equals, that C is actually a point, but yeah, you see, it's fine. 6 squared plus 9 squared. $117 looks like a prime number, doesn't it? I don't suppose you remember the 9's trick from 7th grade, do you guys?
Nope.
If the digits add up and 9 goes into it, it's like the 3's trick. That means 9 goes into this 13 times. So it's going to be 3 squared of 13.
You know when the answer's 3 squared of 13? It's 3 squared of 13.
The book also put decimals, so if you want to do that, I guess it's fine. If you don't have a good calculator.
You should do 8 with this.
Yeah. Number 9, LG. They didn't even draw the line for LG. Actually, let me get rid of all this blue stuff. Okay. LG. Well, I just made a triangle. Do you guys see the right triangle? There's kind of 2 of them.
That's a very nice triangle.
This is a right angle right here. Okay, Jared or Xander, when the radius hits the lines that barely touch the circle at one point are called tangent lines. When the radius hits the tangent line, it makes 90 degrees. Or this is 90 degrees right here. So anyway, we've got a couple right triangles. What else does it tell us? LC is 8. Okay, LC is a radius, right, of the circle. So if this is 8, LA is 8.
Yeah.
Okay, what else does it tell us? AG is 14.
Wouldn't.
Okay, and we're looking for blue here. Is this a hypotenuse or a leg?
That's a
Hypotenuse. So 8 squared plus 14 squared equals x squared.
6.
Kind of big numbers. 260. Let's see, that'd be 4 times 65. I think it's just 2 squared of 65.
Yeah, it is.
Okay. Kind of done with the Pythagorean theorem part. On number 11, name the common internal tangents in figures A and B. So figures A and B are the left and middle. There's a figure C, D, and E on the towards the right side. What do you think they mean by common internal tangents for figure A? Okay, internal just means it goes inside, right? So what tangents do those two circles have in common that go inside?
D and A.
D and A. You guys see it? They're tangents for both circles, and they're going inside the circle. So yeah, D and A, A and D. And what about figure 2, the second picture, or figure B, sorry. Well, it's kind of a trick question. There's none. They have a common external tangent, line L, but it's not going between them, no. It's impossible to go between them on that one. Okay, number 13. Name all point pairs of internally tangent circles. Do you guys see any internally tangent circles?
Oh, was it P, right? Or internally tangent?
No. This is before you got here, Xander, but
L.
circle L and circle N. Okay. So internal for the circles means one circle's inside the other. So circle L and circle N. So you guys remember there's a circle symbol?
We didn't catch that.
Okay, 15. I haven't mentioned this since the very beginning. What figure illustrates a secant? So A, B, C, D, or E. It's kind of like multiple. E. Secants go through the circle. They're not tangent. So figure E.
Or E.
Oh, it says name the secant. What's the secant called on that problem?
Q.
Q. Put a little tail on my Q so it looks less like a 9. Alright.
I'll give
16 hard? I don't know.
It looks very hard.
Probably. 17. A tangent to the circle through P. So it says copy. You don't have to, I mean, you can trace it if you want to, but just kind of vaguely make that picture. And we want to draw a tangent to the circle through P. So not rocket science. I mean, you can get it wrong if you're a little too sloppy Joe or something.
So we could just draw a straight.
We don't really need X for this one. She looks about like that, right? All right, I'm gonna skip 19.
Are we all gonna skip 19?
Yeah. No, you go back, go and do it. Yeah, we're gonna skip it. 21. Yeah, these aren't too bad. Kind of surprised I didn't put through 30. Little bit of algebra fun. How about I make 28 a bonus or something like that? It's kind of the same as the other section, just has some algebra involved. So like Pythagorean theorem stuff, so I'll throw in 28 bonus. All right. 21. So we're supposed to draw this. Two circles having one common internal tangent and two common external tangents.
So would you do like one going through the middle of them diagonally, two on top?
Yeah. So yeah, one common internal, and then external means it has to go outside. So, like, well, kind of missed, but you know, external just means outside. Something like that. Beautiful. Wait, that was 21. Oops. Two internally tangent circles, one having a radius that is half the length of the other. So how do we make sure the other one's radius is half as big? Like if this is the radius of my big circle, where should...
Do, I don't know, cut it in half and do a circle around it.
Yeah, start from right here. Because if I use this as the diameter of the little circle, then its radius would be half as big as that radius. Kind of missed. Shrink. No, it won't be any smaller. There, that's pretty good.
How do you do two circles with no common tangent possible? Two circles next to each other? What?
Okay, what do you guys think? How could you make two circles? How could you draw them so there's no way that they could have a tangent? Common tangent.
But then, no. Wait, what do you mean?
Inside without touching?
Yeah. This picture that we just drew, yeah, it does have one. So, but if we just move the circle over a little bit, then you couldn't. It'd have to like cut through this circle. It would be impossible. So yeah, good thinking.